Hello everyone. In this video, I will speak about the basics of blockchain. In summary, I'll go into detail on what real-life problems blockchain tries to solve, what blockchain is, why it is called blockchain, and what is actually in a block. I'll then give an example of a simple blockchain transaction in order to better explain how blockchain works, followed by its robust security through the proof of work and peer-to-peer network mechanisms. Before we understand what is blockchain and how it works, we need to understand what type of real-life problems it's trying to solve. How do we authenticate something? In other words, how do we know if something is real or fake? For example, a currency bill, an ID document, or an election vote. How do we know whether these are authentic or forged? We keep records of them. Every single currency note has a serial number that is registered with a central bank. Every ID has a unique number that is associated with an individual, and these are registered with the country's Home Affairs Department. And voting registration records are used to check on who voted and who did not vote. If you want to verify the authenticity of a document, you can check with the relevant authority. In addition, we have notaries, who are people officially licensed by the government to act as a witness and attest that a document, such as a rental contract, is legitimate and legally valid. But there is a common theme among all of these documents in the way that they're issued and validated. It is all centralized. There is a central authority, such as a state office, that has the power to issue and validate documents. These authorities have a great deal of power, which can be used to change the facts in the documents if they are corrupt. There are numerous cases where corrupt government officials have used their power to falsely represent information. A great example is the Gürtel case in Spain. Over a span of 10 years, government officials reaching up to the president's office funneled illicit donations and bribes to the then ruling party in exchange for rigged government contracts. This shows that documents can be forged, falsified, and misrepresented for malicious objectives. And this is where blockchain comes in. What is blockchain? Blockchain technology is a structure that stores transactional records, also known as the block, of the public in several databases, also known as the chain, in a network connected through peer-to-peer nodes. Typically, this storage is referred to as a digital ledger. The information is not stored in a single place, but across a number of data servers that participates in the network. This is what we mean by decentralized. There is no central point where the data is stored. It's stored everywhere in the network. It is a system of recording information in a way that makes it difficult or even impossible to change, hack, or even cheat the system. Every single transaction that takes place within a blockchain is recorded on a public ledger, available to anyone in the public to see and verify. Therefore, it is easy for someone to access the ledger in order to verify whether the transaction is legitimate or not. It is an innovative way to implement decentralization, taking power away from centralized authorities and giving it to the users of this revolutionary technology. A fantastic solution for the centralization problem that is present in the world at the moment. It's a system for keeping records for everybody in the system without the need of a central authority. A decentralized way to keep a ledger of records of documents and transactions without the possibility of them being falsified. A great analogy of blockchain is a Google document. I can create a document and share it with a number of people, hence the document is distributed instead of transferred. This creates a decentralized distribution chain that gives everyone access to the document at the exact same time. All modifications to the document by anyone that has access to it are recorded in real time and available to everyone else, making these changes completely transparent. If someone makes a change that they're not supposed to, it's easily seen by every other member of the document. Why is it called blockchain? Blockchain owes its name to the way that it works and how it stores data. The data is packaged into blocks, which links to form chains with other blocks of similar information. It is this act of linking blocks into a chain that makes the information stored on a blockchain so trustworthy. Once the data is recorded in a block, it cannot be altered without having to change every block that came after it, making it impossible to do so without it being seen by the other participants in the network. What is in a block? Normally, each block contains the data for which it is recording, timestamps of when that information was recorded. It will also include a digital signature linked to the account that made the recording, and a unique identifying link called a hash, which is an equivalent to a digital fingerprint to the previous block in the chain. It will also contain the hash of the previous block. Now, let's look at a simple blockchain transaction. Let's assume that a Bitcoin miner just mined a fresh Bitcoin. It is recorded as the first block in the chain, and this is called the Genesis block, which contains information and hash, but no previous hash since it's the first transaction of the block. Every single future transaction using this mined Bitcoin will be linked to block 1. Afterwards, the Bitcoin miner sells the Bitcoin to Atom, creating block 2. This contains information about the transaction, the hash or the digital fingerprint, and the previous hash. After a month, Atom decides to sell his Bitcoin to Eve, creating block 3. Similar to before, this will contain information about the transaction, the hash, and the previous hash. Hence, all blocks contain hashes of previous blocks, a technique that makes blockchain so safe and secure. Let's look at what makes blockchain so secure with a practical example. Assume that a hacker can change the data present in block 2. As a result, the hash of the block changes as well. But block 3 still contains the old hash of block 2. This makes block 3 and all succeeding blocks invalid as they do not have the correct hash of the previous block. Thus, changing a single block can quickly make all the following blocks invalid. How do we circumvent this? Through a mechanism that blockchain uses called proof of work. Hashes are an excellent mechanism to prevent tampering, but computers these days are high speed and can calculate hundreds of thousands of hashes per second. In a matter of a few minutes, an attacker can tamper with the block and then recalculate all the hashes of other blocks to make the blockchain valid again. To avoid the issue, blockchain uses the concept of proof of work. It is a mechanism that slows down the creation of new blocks. Thus, a proof of work is a computational problem that takes a certain effort to solve. But the time required to verify the results of the computational problem is very less compared to the effort that it takes to solve the computational problem itself. In the case of Bitcoin, it takes almost 10 minutes to calculate the required proof of work to add a new block to the chain. Considering our previous example, if a hacker would try to change the data in block 2, he would need to perform proof of work, which would take 10 minutes for each block, and only then make changes in block 3 and all succeeding blocks. This kind of mechanism makes it quite tough to tamper with the blocks, so even if you tamper with a single block, you will need to recalculate the proof of work for all the following blocks. Thus, hashing and proof of work mechanisms make blockchain safe and very secure. A second mechanism that blockchain uses to prevent tampering of transactions is by using a distributed peer-to-peer network. Instead of using a central entity to manage the chain, blockchains use a distributed peer-to-peer network, and everyone is allowed to join. When someone enters this network, he or she will get the full copy of the blockchain, and each computer is called a node. Let's see what happens when a user creates a new block. This new block is sent to all the other users on the network. Each node from each user needs to verify the block to make sure that it hasn't been altered. After completing the checking, each node adds this block to their blockchain. Therefore, all these nodes in the network create a consensus. They basically agree about what blocks are valid and which are not. nodes in the network will reject blocks that are tampered with. Therefore, to successfully tamper with a blockchain, you need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of greater than 50% of the peer-to-peer network, which is next to impossible. This is the secret to blockchain's security. Thank you very much for watching this video. I hope you learned about what is blockchain, how it works, and how it fundamentally is safe and secure. If you liked the video, please leave a like, please hit the subscribe button, share this video with your family and friends, and you can leave recommendations of what kind of content you want below in the comment section. Once again, thank you.